I'm going to be talking about ZNS SSDs in this session. And the title of this talk is Building the ZNS Ecosystem, a Community Effort. So if you haven't heard of zone namespace SSDs, I want to introduce you to the concept. So what we do is we take a logical block device, as the SSD is presented as a logical block device, and it starts with logical block 0 and ends at the capacity of the device. And you're able to write anywhere within the logical block space, and this abstraction is presented to you by the SSD controller. So the twist to what ZNS brings is we break up the LBA space into smaller chunks called zones, and within these zones you have to write sequentially. And zones have to be reset, and the device keeps track of these write pointers for you, and writes that are not at the write pointer will be rejected by the device. So it's a new model of how to send IOs in a manner that's friendly to the SSD behavior. And so what do you get by going with a zone namespace SSD? You get benefits in terms of total cost of ownership. So what we can do is we can eliminate device-side garbage collection with the ZNS SSD. And you also end up having better quality of service by eliminating the device-side garbage collection. So it's delivering on the promised benefit. You know, we have, it's part of the NVMe 2.0 specification. Samsung has announced products, Western Digital has announced products. So it's growing, it's a standard, right? And we're seeing the interest in it. But I really want to hit home the point that it's not a conventional block device, right? And it does need software changes. And another kind of key concern about a zone namespace SSD is that you have to know how the zones are mapped to dies on an SSD, so you do need to have some knowledge of the internals of the SSD to make the most benefits out of the ZNS SSD. And some of these features are actually not standardized, and so we need to work together as an industry and as a group to define what some of these properties of the ZNS SSDs will be. So that was kind of the hardware side, but I also want, this main talk is a lot about software development. And so there is this ecosystem around ZNS SSDs, right, is that we do expose them as a block device if they have certain properties, right? If the zone sizes are a power of 2, in the Linux kernel now, the zone namespace SSD will show up as a block device. You still have to write sequentially within these zones, but it shows up as a block device. If your zones are not of power of 2, then you have to have an alternate solution. And Samsung has developed this character device abstraction to be able to have high-speed async interfaces for the ZNS SSD to be able to deliver get the performance of the device without having to go through the block layer. So it all starts as how the application is able to see the device and work with the device. And we're working through all the layers within the kernel stack. And so we want to let people know that we're there to help deliver the software and work with people to make this ecosystem happen. And we really invite everyone in the industry to work with us. So with that, we also have some layers that help just application developers in general. Like I want to highlight a layer called XNVMe. And what it does, it abstracts interfaces to the operating system, right? Is that you may have different synchronous or asynchronous interfaces that change across, say, Linux or Windows. But if you use this XNVMe layer, you can program to the XNVMe library, and then these underlying storage abstractions are abstracted away from you, and you can switch to whichever one you need. And so this is open source work, right? This is all in open source work, and we invite people to take a look at this and work with us. And I also want to let people know that many people use file systems, and file systems, like it's not as common to have applications that use raw block devices, but file systems will generally move slower in response to something with like a ZNS SSD, and some are fundamentally incompatible. If we look at like ext4 or XFS that do in-place metadata updates, we don't expect to see ZNS support for these file systems. There is preliminary work with F2FS and Btrfs, and so we're supporting these efforts and being behind them and trying to make sure that the ecosystem is developed. And I also will highlight that we have support for ZNS SSDs in QEMU. So if you're interested in building your test systems and without having the ZNS SSD at first, then you can actually use QEMU and emulate the SSDs. And that's work that was driven out of Samsung. And again, open source, free for everyone to see and take a look at. So just wanted to let people know that. So beyond the general ecosystem of how to expose the device and use the device, we're trying to identify a couple of target applications to show off the technology. And when we're doing that, we're saying, we look around and we say, so ZNS demands sequential writes from applications. And the application that popped up again and again was RocksDB. So RocksDB is this log structured merge tree, and it's a KV store, but what it does is it writes data out sequentially. It first buffers it into memory, and then it writes out larger sequential chunks and sequentializes all of the I/O. And so RocksDB is a perfect fit for ZNS, and we have a demo running RocksDB on ZNS in our booth. And the key feature of RocksDB that makes it very interesting is that it can be a storage engine for MySQL. So by having this RocksDB support, then you can end up having MySQL support for ZNS SSDs. And to enable RocksDB, we actually worked on a thin, lightweight block allocation, we call it, like block/object allocator, but they're nameless objects. And so this is the underpinning, this is user space software that we created that people would hopefully use to build their storage abstraction. So we're trying to modularize our approach. We don't want some monolithic software approach, and we're hoping that other people recognize that they could use some of this software in their projects. And so what we're trying to do is be very open and transparent of what we're building and how we're building it, in the hopes that other people will either join us or reuse some of this software. So again, just saying that it's all open source. Oh, one other thing I'd like to add too is that we recognize that file systems are important, and so we did build a user space file system component using Fuse to be able to expose the data that was generated from this RocksDB instance on ZNS. So you can mount a file system that shows the files that were written to the ZNS drive and copy them out, move data around, and use your existing tooling. Okay. And so the main kind of thing that I want to bring across here with this talk and really is that this building the ZNS ecosystem does not seem like it's an effort from a single vendor, right? I believe multiple vendors should be involved, right? And we should work together with partners, people that have the applications where it makes sense to use ZNS, and we should all collaborate together. And I think open source is a good medium for doing that. And so I want to say, definitely bring it home, right, that we are involved in Linux. That's one way of just exposing the device. This, again, I mentioned this XMVME layer that helps to build storage software, and it's not trying to do everything for you, right? XMVME is just a virtualization layer for access to storage interfaces. That's its main job. It does nothing else other than that, and it's very lightweight. There's the FlexAlloc project, and this is released on GitHub. So XMVME is on GitHub, FlexAlloc is on GitHub. All of our work in RocksDB is open source. You know, we haven't released all of the RocksDB work, but as we develop it and work on it, our plan is to release open source as the project matures. So, so in summary, I'd like people to take away that ZNS has arrived. So these zone namespace SSDs have arrived. They deliver on the promised benefits, right? We see quality of service improve. We see the no need for over provisioning on the SSD, leading to a lower total cost of ownership. But at the same time, it's not a drop-in replacement for your existing SSDs. There are software changes that need to happen, and so we have to be ready for those software changes. And there's limitations in the current software ecosystem. So I mentioned this power of 2 zone size. But we're well aware of it. We're developing solutions where you can still get high-speed access to the device by not going through a block device, and Samsung is in the open source. And I'd actually like to bring up that we've also started patches for simple copy support. So another device-specific feature that we're adding in Linux is that you would be able to copy data from a zone to another zone internally to the device without bringing the data to the host, right? So we can have device support for a copy that's totally within the device, right? And so we're working on support for that. And so there's software problems within the ecosystem. We also are working on hardware solutions to address some of these solutions, specifically these problems for ZNS. And so we're actively working in this area. And I want you to join us, right? I hope you come visit us in the booth. Come talk to us if you're interested about ZNS technology and software. I want to learn more about your software. Samsung wants to learn more about your software and collaborate together through the open source community. And so yeah, everything's open source, and we want to know about your challenges. And if you're interested in ZNS, come talk with us in the booth. And then there's some links. So look for these projects on GitHub, FlexAlloc or XMVME, and you can chat with us there. And we're open to asking questions and talking about the software. And Yeah, just want to let everyone know, but visit booth 14, come talk to us about, say, ZNS. We have CXL, Poseidon, a lot of interesting projects from Samsung, and I'd just like to thank everyone that was involved at Samsung for ZNS and all the projects that we have here at OCP. All right, thank you.